Okay, we are on chapter 5. We're reviewing our open book test. Question number 1 reads, if the yield to maturity of a bond increases, what will happen to the bond price? So the bond price will decrease. Now, bond prices are based on the present values of their future cash flows, which are discounted at the yield to maturity, the YTM. So we alluded to the fact that when YTM, which is a discount rate, if it increases, so this means that it will reduce the present value of the future coupon payment. That is just how it goes. So meaning this will cause the bond price to fall. So following up yesterday's question, we ended at understanding what the yield to maturity is and how to calculate YTM. So we looked at an example to say YTM is actually a discount rate. It's given by the coupon payment plus the face value minus the value of a bond divided by n over 3VB plus MV divided by 2. So suppose we have a bond whose face value is 1000, and this bond is a 10-year bond, and this 10-year bond is to be issued 2 years later. After 2 years, that's when it is issued. So meaning the duration of this bond should be how many years? N minus 2, because this is effect into years, so our n therefore will be 8. So our n will be 10 minus 2, which is equal to what? 8. And we're told that it has a 10% coupon interest, so our coupon interest is 10%. And the selling price of the bond is 1,200. So find the KD. So the KD is actually our market year to maturity. So yield to maturity, what did I say was the definition of yield to maturity? Yield to maturity is actually the total return that an investor can expect to earn if a bond is held until it matures. So we're assuming all interest payments are reinvested. So in simple terms, what we're talking about is that if you buy a bond today and keep it until it matures, what will be your average annual return? So that is the yield to maturity. So it's actually your discount rate. So here we have a 10-year bond issued after 2 years. So meaning the period of time we're going to look at is 8 years. So the face value is 1,000. And the coupon interest is 10%. So 10% of 1,000, it will give you the coupon payment, which is 10% of 1,000 is what? 100, right? Are we following? So 100.
Yes, yes, yes.
So the payment here, we're going to put 100. What is the MV? 1,000. And what is the VB? 1,200.
1,200.
The N?
8, yes.
Yes. Over
So, Mr. Collins, this PMT is for what?
the payments, just the same as the capital,
Oh,
capital
okay.
I.
Okay.
1,200 as the face value, which is 1,000, over what? Over 2. Okay. So this will give us a yield to maturity, which is 6.6%. Okay. So that is that. Are we together?
Yes, so the final answer is 6.6%.
Yes.
Okay.
That's the final answer. So you need to understand that there's a relationship between the yield to maturity and the bond price. Okay? So they have an inverse relationship. So we have our YTM here and the bond price. So what happens is that as the price of the bond goes up, the yield to maturity will go down. And as the bond price goes down, the yield to maturity will go up. This is a relationship that we have. It's an inverse relationship. Okay? P1, P2 cause the yield to maturity to go down from, okay, Y1, Y2. This inverse relationship is explained. Even in the calculation, you've seen how that the bond price, which was 1,200. So if we increase our bond price from 1,200 to 1,300, it will reduce the yield to maturity. Okay, so why is it the case? Because the yield to maturity will actually reflect the return you earn. So what you pay for the bond today is its price. So the fixed interest payments are the coupon and the face value repaid at maturity. So if the bond drops, it means you're paying less now, but you're getting the same fixed future payments. So if your return, which is the yield to maturity, increases, it means the bond price will decrease. But if the bond price increases, you're paying more upfront. So the yield to maturity will decrease. Now, I was just trying to explain the other question on the multiple choice here to say if the yield to maturity increases, what will happen to the bond price? It will decrease. This is because the price of the bond prices yield more in the opposite direction. So as yields increase, the present value will fall down. Okay. Then question number 2, which of the following bonds is most sensitive to interest rates? A 2-year zero coupon, a 2-year bond with 10%, a 10-year bond with 10% coupon, or a 10-year bond with zero coupon. So the answer is D. Okay, so our answer is D. So the 10-year bond with zero coupon. So here interest rate sensitivity is measured by duration. So looking at a zero coupon bond having no interim cash flows. So the entire value is received at maturity. So it makes them more sensitive. So the longer the maturity, the greater the duration. So we'll look at our sensitivity when dealing with elasticity, which I didn't talk about. Okay. Then question number 3, the relationship between bond price and yields is what? It is negative and convex, like I showed the curve. So the price yield is downsloping. That shows convexity. So this means that the bond price increases more when the yield falls down, and it decreases when the yield will raise by the same amount. So that shape that I showed you is called a convex shape. This is how convexity looks like. This is a convex shape. All right. So go to question number 4. Question number 4. A modified duration measures what? Coupon size, maturity time, interest rate sensitivity, and risk premium. So it measures modified duration estimates. So modified duration estimates how much a bond price will change with a 1% change in yield. Okay. So when you're dealing with a modified duration, it is used to estimate the percentage change in the bond price for a 1% change in yield to maturity. Here we use the Macquarie's duration. So the formula, those that have joined the class, I don't know that you remember, I also sent you the notes, is given by the following. So the duration formula is given by Macquarie duration, 1 plus u to maturity over m, where m stands for the number of compoundings. Okay, where m stands for the number of compoundings. So we can look at an example in the calculations. But what concept we're trying to raise from there is that when the market rates will fall, the fixed coupon payments will become more attractive. So investors will be more willing to pay a premium for a higher than market returns. So the bond prices will rise. So in an instance where you buy a bond that pays 10%, but the market rates will fall to 8%, the bond will trade above par. So that is a formula that we use when we're dealing with the modified duration. All right, question number 5. When interest rates decrease, the price of the bond will do what? Will increase. So as interest rates drop, the fixed cash flows from a bond will become more valuable. Okay, all these are there in the notes that I sent today. Now, let's look at the short word answers. Define the term bond convexity and why is it important in a bond valuation. Convexity, what does this term mean? So it is important because it captures the curvature of the bond yield relationship. So it is important because it accounts for this nonlinear relationship of the changes in prices and also enhances the accuracy when we are estimating the price of the bond during a large interest rate shift. It also explains why prices will rise more when the yield will fall down. Okay, so that is why it is important. Then question number 7 reads, differentiate between the modified duration and the Macquarie's duration. Okay, so the relationship between the two is in definition. Macquarie is simply the weighted time to receive the cash flows, whereas the modified duration measures the sensitivity of the price to interest rate changes. So the units that Macquarie duration has is in years, whereas the modified duration is a percentage, a 1% change. Then where do we use the Macquarie duration? We use it when we're measuring the bond time profile, whereas modified duration just measures the interest rate risk. Okay. Question number 8. Why do zero coupon bonds have higher durations than coupon paying bonds? So it's because they do not have what? A periodic interest, or the cash is received at maturity. This is for the zero coupon. This means that the average time to receive money is longer, so increasing the duration and sensitivity to the interest rate changes. So that's why the zero coupon bonds have a higher they pay higher also. They have no interim cash flows or payments and paid at duration. So they have a longer average duration. And the longer the duration, the greater the volatility. So it implies that here investors holding zero coupon bonds are more exposed to interest fluctuations. Any questions? Okay. Then question number 9. If the bond price rises more than the expected rate, it will cause an extra increase. If the bond's price raise more than the expected, more than expected, if a bond's price rises more than expected when rates fall, what causes the extra increase? Okay. If the bond price rises more than expected, what causes the extra increase? Well, the extra increase is due to the convexity. So bond prices changes are not linear. Okay, they are non-linear. So the convexity is what makes the bond prices increase for more rate declines. So this convexity is what makes it extra. The relationship is convex. Okay, I repeat, convexity is what causes the bond price to increase. So meaning bond price changes are not linear. It's a convexity that causes bond to rise sharply when the yield fall. So this gives the investor some positive convexity benefits. So now question number 10 has some calculations. So we're given that a modified duration is 0.8. Estimate the percentage change if the interest rates fall by 0.5%. So here we want to calculate the price change. So the price change is given by um, minus modified duration times the yield. So in this case, we have our duration, which has been given as 0.8, and the change in that's a 0.05% change in the price of interest. So you multiply the duration. Negative is part of the formula times the change. So this is 8 negative times the change, which is a 4. The negative that is here is because it is a decrease. If there's an increase, we have added a plus. So our final answer is 0.4. So meaning the bond's price expected to increase approximately by 0.4. Bond price will increase by 0.4. Okay, then we went to the second section where we're looking at computations for a bond price. So a bond has par value of 1,000, coupon interest of 12%, and time to maturity is 3 years. What is the value of a bond? So the bond has a coupon of 12%. So you can do this in two ways. The value of the bond formula or the direct narration. Remember, the value of the bond is given by what? The coupon value and the present value annuity plus the maturity value or the face value and the present value interest factor. Or we know that this is going to last for 3 years, and at the end of the third year, you'll be given back your initial sum of money of 1,000. So 12% of the initial amount, that is 120. So 120 over 10%, 120, 10%, then second year 120, 10% third year. Then in the third year, you'll be given back the 1,000 at the same market rate of 10%. So if you calculate that, you're going to get a what? 1049. That is your value of the bond. Okay, you can still use this formula to get the same value. 12% of 1000 is 120. And the face value is 1000. Then you go to the table, 10% under 3. Have we been taught how to use the financial tables?
Yes, you taught us.
Okay, so you need to check on the present values. Okay, so these tables will be given to you. So I taught you how to use the manual way, which is my preferred way of teaching. Without the tables, you still know how to answer or find the values of the discount factors. Okay, especially when you have decimals. But needless to say, we can still um, look at how do you okay. I hope you can see the tables here. So you check on the present value tables, the future values. So you go present value, this is future value, present value table. So 10% under 3 years. So here we have 0.71. Are you able to see where it's coming from?
Yes.
'Who said the 10% under 3?
I'm seeing 0.751.
0.7, yes, thank you. So we go there, 0.71. So that's 0.71 that we have here. Then we go to the present value annuity. We go back here. So we go to present value annuity. So give me, this is future value annuity. And again, another future value annuity. Let's check present value annuity here. So check on the 10% under 3. What value are you seeing there?
2.487.
2.487. Okay. So what's the final value here? How do you get when you compute that?
That's just the moment. Let me try.
I'm finding 1049.44.
Oh, yeah.
So you see it's the same value, right?
Yes.
Okay, so you need
Hey,
to
me, I prefer this one more.
this one here,
The one up,
the one we
not
did.
that one. Yes, I think that one is the best for me.
Okay. So either of them is okay. You need to understand the principle. This one also is simple. This one is actually you're preferring the tougher one because we started with it like that. All right. Then we have a 5-year bond to maturity, a 6% coupon, face value is 1,000, selling price is 950. Calculate the yield to maturity. Okay. Now yield to maturity, uh, with this it's guesswork. Usually it's interpolation. But remember the formula we use for yield to maturity. What's the formula for yield to maturity? Yield to maturity is got what? Coupon payment.
I'm kind sorry, I'm kindly
I
asking if you can go down a bit. I just screenshot the answer on top.
I guess.
Yes. Okay, thank you. You can go ahead. You can proceed.
So yield to maturity is got what? I. Then.
plus
Mm-hmm.
MV
Mm-hmm.
minus VB
Mm-hmm.
over N
Mm-hmm.
over 3VB
Mm-hmm.
plus MV
Mm-hmm.
over 2.
Okay. So what is our I? Sixty kwacha minus what's the MV? 1,000
1000
minus VB 950
950
over N 5
5, yes.
over 3 times 950 plus what?
1000
1,000
over
over what?
2.
Over 2. So this will give you 7.4. So what kind of a bond is this? This is a discount bond. Okay, because the coupon interest of 6% is smaller than the market rate, which is a rate maturity of 7.4%. All right, so um, you if you're using for this one here, it's guesswork. So what they did here, they were trying percentages. You start 8%, to give you a number, it should be close to this number. So this one is not very attainable. If you're going to use this method, you need to come up, because this is guesswork. You're simply using what? Guessing which amount, if you're going to put in there, should give you an amount equal to or close to this. So you need to try a number of them. But this one will give you a certain range that will just be within the percentage you can guess. The one that was called interpolation. Are we together? Is that clear?
Yes, it is.
Then estimate the percentage change in price using the duration formula. So duration formula, percentage change in price is simply given by so I'm really particularly interested in you understanding almost all the calculations I got from the chapter, because most of the questions are coming from your textbooks. So it'll be easy for you as we go through, understand how the calculations are done. Okay? So In calculating this, we're just simply multiplying the modified duration times our percentage change in the price. Okay, this will give us our estimated change in price using the duration formula. We multiply that 10 point, because negative is part of the formula. Negative 10.9 times, this is an increase by 0.1%. One increase by 0.1. So this is that, multiply that. So our percentage change will be down by 10%. Now, a zero coupon bond has a face value of 1,000. Time to maturity is 4 years, and the price is 700. So you can still use the same formula for the yield to maturity. We will say zero coupon bond, so there'll be zero coupon payment there. So here there'll be 0. Okay, so yield to maturity will be what? I plus VB, MV minus VB. So I'm removing the payment part because it is 0 either way, over N, everything divided by 3 VB plus MV over 2. So if we substitute all these figures, the yield to maturity will be 9.37%. So you need to practice this in your own time. Then in the evening, you look at elasticity of bonds. Then we are done with the evaluation of bonds. So we end here. Thank you so much for your time. Those that managed to go through the open test question, you could still go through and send me your solutions.